Yeah. Okay. So mostly today we will discuss a couple of things. First of all, some applications which will mostly involve passing pointers to functions. And second, we will look at the equivalence between arrays and pointers. In some sense, they are exactly the same, and in some sense, they are not exactly the same. But anyway, we will look at these two topics today. Okay.
Sir,
First
are
of
you sharing your screen, sir?
Strings are there, yeah.
Are you sharing your
Screen is already
or
shared.
it is not visible?
I think screen is already shared.
Screen
Is shared. Now recording is on. Yeah. So I do not think that there is any problem. Okay.
Is visible, sir.
What?
Screen is visible.
Yeah, screen. Okay. Okay. So in a function, so whatever it returns, let us not worry too much about this for the moment. Let's say I want to send a pointer p. It's an int pointer. So instead of writing int p, just write int star p. If you want to send another pointer, just send int star q. If you send a character pointer, star c, and then other things, maybe int n, float f, and so on. And then write your function. Okay, a function can also return a pointer, but let us not worry too much about this. We will come to that possibly tomorrow. And then write your body here, function body. Okay. So what will happen when you pass a pointer is that maybe let's look at this. Okay. Inside main you have int I, int j. Okay, sorry. Maybe I'll write using commas. Maybe something like int I, j, k, n. Then you may have declared float x, character ch. Okay. Then you can make a call something like this. Okay. For example, I want to send a pointer to this integer k as p. So you just pass it as address of k. Okay. And maybe as q, you want to send a pointer to I. So you say and I. Okay. And this is a character pointer, so you just send and ch. Then maybe you send n, float x, you send x. Okay, so this is the basic parameter passing mechanism. Now, what will happen inside this function is that this variable k visible as star p. Okay, if you make any change in star p, that will be directly reflected to k. Likewise, if you make you have sent a pointer to I as q. So if you change star q, Okay, this is same as I. Okay, so this is again visible. I is visible inside the body as star Q. Okay, so this kind of parameter passing may be called passing by reference. You may call it, but it's nothing but call by value because the address to K is copied and sent to this. But whatever the copy of an address is, wherever they are pointing, that is unique thing. So any change you make to this pointer C, star C equal to something, those will be reflected in this. Whereas this N and this X, they are in a sense passed by value. Therefore, if you make any change to this N or this F, they will not be reflected in this N or this X. This is fine, right? And that is one way we can handle passing things and passing things in order to change them. Okay, so this example illustrates this. So maybe I just once again come back to an old example. So I didn't cover fully. Where is that? Yeah, this one. Okay, so let us say you have two variables, int variables, storing the value 51 and 23, and you are simply calling a bat swap function, and these calls are by values. So 51 will be copied to this instance of A, 23 will be copied to this instance of A, B, and inside this function, whatever you do, you are essentially swapping this instance with this instance, but no change is reflected in this A and this B. Okay.
Sir, function needs a return statement.
Function?
Void bat set needs return statement.
No, this is a void function, so nothing.
Void function.
Sorry, sir, but
nothing needs to be explicitly returned. You can write return semicolon here, but that is obvious. Because at the end of the function, it will return anyway. Okay. Okay, so let's see. So inside the memory of main, two variables A and B int type, storing the values 51 and 23 are created. Then we make a call bat swap. Okay. So this A, this 51 will be copied to this formal parameter A. Okay. So this A stores a copy of this value, this B stores a copy of this value. Okay. Next time when you refer to this A and B inside the swap, it will essentially access this copy. Nothing will happen to this A and this to this B. Okay. So if I declare a temp pointer, so temp equal to A means 51 will come here, 23 will go here, then 51 will come here. So it's something like this. Then 23 will come here, 51 will go here. Okay. So when the function returns, definitely some interchange or some swap has happened, but it happened only in this local, or I would say these parameters A and B, which behave like local variables. Nothing happens here. Okay. Now, let us replace this bad swap by a good swap, where instead of passing A and B directly, I am sending pointers to A and B. And now if I access star A, which is basically a pointer here, that will
Excuse me, sir.
access this A. Yeah, tell.
Hello. Sir, in the function, we can use any variable like x, y instead of a, b.
Oh, any name you can use. Any name you can use. Yeah, that's true. That's true. Any name you can use. In fact, you see that.
I'm asking that variable name should not be same, right, sir? It
No,
may
no,
be
no.
same or may not.
Maybe some
Okay.
you can write x and y because this is just a value copied here. This is a value copied here. And instead of saying A and B, you could have said A plus B, B minus A, something like that. Full expressions are also allowed here. Okay. So it will be evaluated and that will simply populate this formal parameters, which happens to be of the same name A and B. Okay. Okay. So now instead of passing A and B directly, I am passing their addresses. Okay. Since these are addresses, so this A is no longer an int variable, it's instead a pointer. Okay, int star A. So A is a pointer, not an integer. It's an int pointer. Likewise, B is an int pointer. Okay. So now if I access whatever that pointers are pointing to, they are basically same thing as this and this. And therefore, if I make any change there, they will be visible here. Okay, and now let's see how it works. Okay. So as usual, mains memory contains A and B, and then I make a call. This call, what it does, it creates two pointers. Now, instead of writing AP or something, I'm again calling it A. Okay, there is no problem with whatever name you give. It can be X, Y, it can be A pointer, B pointer, something like that. Now, what happens is A and B values are not exactly copied, but addresses to A and B, they are now passed to the function. So this is a copy of the address. This is a copy of the address, but this is again, I would say passed by value, but now my address is copied. Okay. So now when I say temp equal to a star, okay, first say int temp. This is just a temp variable. Now when I say temp equal to star A, this A now refers to this A, not this A, but star A refers to this 51. So this 51 will come here. Okay. Then when I say star A equal to star B, whatever this is pointing to, this will get the value of whatever this is pointing to. So 23 will come here. Okay. Finally, whatever is stored in this temporary variable, this will go to whatever this B pointer is pointing to. So 51 will come here. So that produces the desired effect of swapping A and B, and that is possible in C only via call by reference. Okay, so you instead of sending A and B directly their values, you send their addresses, and since these are addresses, whatever they are pointing to, that will be visible from inside. Is this clear? So this is our first application of pointers. If you want something get changed.
So what is the difference in these two methods?
Huh? What?
Sir, what is the difference in these two methods?
Difference means you can see that now these values of A and B are swapped. Earlier they are not swapped.
Yes. Yes, sir. Both are doing same. Then what is the difference in this process? I mean,
No, you are
what is
passing
the
a pointer.
advantage of this process?
Here you are passing a pointer and accessing whatever is pointed to by that. So this pointer, this is a local copy of a pointer. Okay, so this is again a copy, no problem. The address of this is copied here. Address of this is copied here. But since these are addresses, how many copies of this address I make, it doesn't matter. They always point to the same thing. Okay. If I make another copy of B, like say P equal to B, and then star P and star B.
I am asking,
Uh-huh.
so is there any advantage to do so? Sir, I am asking that, is there any advantage to do so?
Advantage means without this, you could not swap A and B from inside the function. It was impossible.
Sir, we can do same in both in previous example. We did like
Okay, let's look at start. Let's see. This is 51, 23. I want 23 to come here and 51 to come here. Of course, I could have write T temp equal to A equal to B, B equal to temp inside this. But if I want to make it via a function call, and I simply pass their values, nothing happens here. 51 remains 51, 23 remains 23. There actually happens a swap, but that happens inside bad swap's memory, not outside. Okay, this is the swap. So when this function returns, or throughout the execution of the function, nothing happens to this A and B because their values are only copied. Okay, that is the reason I copied not their values but their references. So I am sending pointers to these samples. This pointer is a copy.
okay, sir. Okay, now I'm okay, sir.
Okay, so this pointer is a copy, no problem. C never deviates from the philosophy of call by value. So this is also a call by value. But the value that you are passing is not the value itself, but a pointer. Okay. And since this is a pointer, wherever this is pointing to, that is visible from outside. Okay. So now temp equal to star A, not A. So this 51 will come here. Then 23 will come there. Finally 51 will go there. Okay. So without this way of doing things, you cannot make standard int, float, character values visible from inside a function. So if you want to change something, you have to pass it this way. Okay. So there is no other way actually. Okay. So is that fine? The difference is understood, right?
Yes, sir. Yes, sir.
Oh. Okay. So this is one application. So maybe I just write it explicitly. So application 1. So make things visible from inside a function. Of course, sometimes it is possible to effect a change by means of a return statement, but this is what my second application is. Something like multiple returns. Okay, in fact, swap was an example of multiple return because you want to change both the values of A and B. But if you have a single int type return, then you can either return A or return B, and then there is a problem, right? You want both A and B to change. Okay. So let me give you a more elaborate example. Okay. So suppose that I want to. So I just write it. It's a trivial code. So I'm not writing the exact code for it. So let's say I have an int array A with n elements, and I want to compute both the minimum and the maximum of this array, and I want to store it, let's say, int star min, int star max. Okay. In general, if there is a function called min, it can return this min. There can be a function called max that will return max. But if I want a function to compute and, in a sense, within quotes, return both min and max, so this is one way of doing it. Another way is definitely you can clap together the two values in a structure and return that structure. Okay, so this is another way of doing it. So it's something like this. Maybe let me just use some int I. You initialize min and star max to A0. I assume that n is greater than or equal to 1. So assume okay. Then for I equal to 1, I less than n, plus plus I, if AI is smaller than whatever this min is currently storing, just say star min equal to AI, and if AI is bigger than star max, just say star max equal to AI. That's all. So this example illustrates that you can actually compute a couple of things, and both the things are returned via these pointers. Agree or not? So this is a case of multiple return in a sense. Is it fine or not? Tell if you have any query.
Sir, min and max are pointers, but we are sending we are sending the memory address of some actual variables in the real calling statement, right? So
Yeah, correct. So you want to see the main function. Maybe something like this. Let us see the main function. Maybe you have an array int a 100 n x y, and then maybe you scan the individual elements of a, and then you simply call min max a n and x, then x will store the minimum, and y, then y will store the maximum. Okay, then you print x, it will print the minimum. You print y, it will print the maximum. Fine, right? Yes or no? Okay, since there are no questions, I assume it's fine.
yes, sir. But yes, sir.
Okay. Okay. Okay, so before coming to the next topic, pointers and arrays, their equivalence, I also give an example of what is called a pointer to a structure. Okay. So this is pointers are structures are nothing but more complex or compound data types than the elementary things like int, char, float, double. Okay. But otherwise, they are similar to this int, char, float, double because they are always passed to the function by copy, by value. Okay. So for example, let us look at our struct stud. Character name 100. Character rule 100 or 10 suffices. Float CGPA and int edge. Semicolon. Okay. So now if I want, let's have some main. This is my main somewhere here. I have struct stud S1, student 1. Okay. And then if I call F and S1, okay, so if I call GS1, then this will be just copy by value. In other words, whatever changes you make in this name array or role array or the floating point value CGPR of edge, that will not be reflected in S1. But if you send, or maybe I use capital S, I use capital S here, and S1, then a pointer to this kind of structure is sent. And then if I say star S1 dot name, I make some change there. Those things will be visible in S1. This is exactly the same as int, float, double, the elementary data types. Okay.
Excuse me, sir.
Yeah.
Sir, what is F and G here?
What is?
F and G.
Maybe I will write the function f. F and g are some function. I will write the function f. Okay. So if struct stud pointer p. Okay. Then star p means a structure of the form struct2. Okay. So it has this component name, role, CGPA, and age, where name is a 100 character long array, role is a 10 character long array, CGPA is a floating point variable, and age is an integer variable. Okay. So I can, for example, say string copy star p dot name yes. Okay. I can also, I have already introduced this notation earlier. Instead of star p dot name, I can use this symbol. minus greater than. Okay. Maybe 20 y s 2310. Okay. Then I can say star p dot CGPA 8.69. Or I can also say P. These are two notations. Both you can use interchangeably. 30. Okay. So star P dot is same as P this. Okay. There are two ways of referring to individual members of a structure when you specify a pointer to that structure. Star P dot, this is the direct way of doing it. So star P means dereference it, you get that structure, and then dot means you access that particular member. Or this star and this dot, they can be clubbed together in this notation. This is a double thing. Minus followed by greater than. Okay. So P is whatever P is pointing to, that kind of that member. Okay. So this is what is called, this is how you can make the members of P visible inside the scope of the function. If I make any change to the CGPA age, role, name, those will be directly visible to this structure S1. Okay. In principle, this is exactly the same as if you are passing an int variable or a character variable or a double variable, things like that. All these elementary types. Okay. So I would say this is conceptually nothing new. Okay. Yeah, tell me if you have any query.
Sir,
Yeah.
what if we remove the parenthesis around star p in star p dot name? Means what is the precedence?
I think it should work because P is a pointer, so pointer dot name does not make any sense. So star should have higher precedence than dot. I think this will work, but I often use this in order to increase the readability of the code, and just I would say to stay safe. But I think this will work without this parenthesis. Because P dot name makes no sense because P is a pointer. A pointer cannot have something, some component like name, right? So.
Sir, but
Okay.
in the slide it was written that the dot operator has the highest precedence.
No, then I have to check. Actually, I have to write a code and see what actually happens.
Okay, sir. Okay.
This is my personal, I would say, coding practice. I always use this parenthesis, but it seems that even without that, this will work. But anyway, we have to check it. But anyway, it's always preferable or safe to give this parenthesis. It doesn't hurt, right? Okay.
Yes.
Yeah. So that's about a couple of applications. Making things visible from inside a function and affecting multiple returns. Then comes the second important thing, with which I will spend the rest of today. So arrays are pointers. Okay. So as an example, let's say int a 10 and star p. Okay. You can see that a is actually an array of 10 integer variables, whereas p is a pointer. But this is a static array, a equal to something, not allowed. But since p is a pointer, p equal to something, this is allowed. This is not allowed, this is allowed. So,
In P, it's pointer, so what's the value? Star is a pointer. If you don't initialize it with any memory address of any variable earlier, then what does it store initially, like null value?
Garbage, not necessarily null value, garbage.
Garbage means any memory function it will be pointing.
If you have int n, and if you do not initialize n, it may contain anything, not necessarily 0. Here also, you are just declaring that p is a pointer. You have not initialized it. It may store anything, null value, garbage value. Don't try to follow a pointer which is not initialized. Most likely we will enter segmentation.
Okay, sir.
Okay.
Okay, sir.
Oh. So,
means only
yeah, tell.
and video.
Your transmission is very noisy and nothing I could get.
That is only address. So
No, I do not hear you. Maybe you just write something in that chat box. I want write something in the chat box. Your query in the chat box. P equal to something means, yeah, something means, of course. Something means, yeah, I will look at example. Something means some address, some valid address. Okay, here also something means address. What I mention here is that you cannot have A, because it's a statically defined array, on the left side of any assignment statement. But P you can have, because it's a floating pointer. It's just, you can assign any address there. Okay. So here, for example, I can say A. Okay. But A equal to P is not allowed, although they are of the same data type essentially. But this is something like a constant address. You cannot change it. But this is a variable address. You can say P equal to. After this, what happens is P essentially behaves like arrays. So you know you have these 10 elements, A0, A1, A2 up to A9. After this, P equal to A allocation or assignment, you can also individually refer to the array elements as P0, P1, and so on, P9. They will be the same as A0, A1, A2 up to A9 respectively. So this is allowed. Okay. Although P is a pointer, but since pointers and arrays are essentially the same, after this assignment, you can access this array elements as P0, P1, P2, P9. Okay. In fact, you can do something like P equal to A plus 5 also you can write. So just skip 5 elements and write, and let your pointer P start from the element at index 0. Okay. Then what happens? So let me write down A0, A1, A2, A3, A4, A5, A6, and maybe just A9. Okay. So when I say P equal to A plus 5, so I am speaking 0, 1, 2, 3, 4. Now P is pointing to this element. So now if I say P0, this will refer to A5. P1 will refer to A6. And P4 will refer to A9. What about A4? This is P minus 1. This is P minus 2. P minus 3. P minus 4. P minus 5. Is this clear?
Excuse me, sir.
Yeah.
Sir, why did not you use ampersand before A while you are assigning the pointer?
Okay. In the last class I have seen, I have told that if I add an integer to a pointer, it essentially means skip 5 elements.
No, sir. Sir, first assignment P is equal to A, you did not use ampersand there. Why, sir?
That is why I mentioned A is already a pointer. A0 is an integer. A1 is an integer. A2 is an integer. But A itself is already a pointer. It's not an integer. It's already an int pointer.
Sir, already a pointer. It is itself an address.
It's itself an
Sir, then why you use ampersand in a scanf while taking the value of array?
You can also write this, and this has the same effect. You can also write and A0. So now this square bracket 0, this now refers to an element, and you are taking the address of that. Here also you can just say P equal to and A5. This statement and this statement are same. Likewise, this statement and this statement are the same. Okay. A itself is a pointer, but A0 is an int, and if I want the address of A0, then I have to use and. Here also, A is a pointer, skip 5 ints, whatever that address is, assign that to P, or straight away I can say A5, the fifth the element at index 5, and take the address of that. Okay, so these and these are same. These and these are same, these and these are same. But A itself is a pointer, so I don't have to say and A. And A is a pointer, so A plus 5 will again be a pointer. So I don't have to say and of that. Okay. Is the question answered?
Yes, sir.
Okay. And after such an assignment, I can use P as an array, P0, P1, P2, P9, or here P0, P1, P4. Even I can access P1 minus 1, P minus 2, P minus 3, P minus 4, P minus 5. Although here these indices are negative, they are still in a valid location of the array A, which I have declared like this.
Sir, but what value will the negative indices carry?
Whatever A0 is storing, P minus 5.
No, P minus 5 will be what? P minus 5, for example, P is equal to A minus 5. That means P is equal to A of minus 5, right?
No.
Then?
So you mentioned something like this. P equal to
A minus 5. Yes.
Okay. This is not same as is same as okay, so this is not same as, it is same as this. B is an address, A is an address, but A minus 5 is a value. You cannot assign a value to an address. Compiler will give you a warning, and when you run such a code, most likely you will encounter segmentation fault. Okay.
So that I understood. I'm saying that I think I visualized it as the second option only. But what if I'm saying printf %d, P? Then what will it show?
Wait.
Printf
What are you printing? Are you printing P or star P?
Star P.
Star P. Okay, so whatever is there, it will print. Okay, let's have an array A starting here. So A is an address 0, 1, 2 up to 9. Okay, and maybe which one? Let us not do the illegal thing. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So when I say P equal to A plus 5, let us say A contains these things. 2,
that
1,
means P is ampersand A of 5.
Yes. Let's give some values. A
the sixth member.
Yes. Okay. So you say P equal to A plus 5. So 0, 1, 2, 3, 4, 5.
Yes.
So P will point to this.
4.
4. So if I print star P,
4.
This print 4. If I print P2, it will print 4, 7, 0, 1, 2. It will print 8. If I print P minus 3, it will print what? This is 0, minus 1, minus 2, minus 3. It will print 5. Happy or not?
Yes, but initially the P equals to A plus 5, that I'm not doing.
That you are not doing?
Yes, and then I'm saying that P minus 3 is what? And what will it be?
No, if P is uninitialized, then you will get something garbage. First, you have to set it to some address, right? And then you can talk about whatever is plus.
Sir, I am probably not being able to understand. P is equal to A P equals to A means A of 0.
And A of 0.
And A of 0, right?
Yes.
So P of minus 3, if I print, then what will it print?
Okay, if you say P equal to A, and you want to print P minus 3, minus 1, minus 2, minus 3. Whatever is sitting there, it will try to print. That is actually outside your array, right? So whatever is sitting there is not under your control. Is the question, is the answer clear now?
Yes, sir.
Maybe some I, J, K, L, M, something, some other variable is staying, or maybe it's outside your allocated memory. So in that case, you will encounter segmentation fault.
Okay.
But if you know that P equal to A plus 5, you have said something like this, then it is legal to access P minus 3. You know something is sitting there, and that is part of your intended array A.
Sir, but in the left case, sir, it won't be an error, right? It will give some output, but the output is what that we don't know.
Yeah, it won't be an error because
But,
C never makes any range check. It will try to access whatever is there. It will try to access. If it can, whatever it reads, it will say. If it cannot, because of permission issues, you will encounter segmentation fault. That's it. It is entirely up to you to ensure that whatever array index you are accessing is a legal part of your memory, and so on. If you do not ensure that, your day may be spoiled. That's it.
okay. Thank you.
Okay. Yeah. Yeah, these are good questions, but you should be careful about programming in things in C. C does not help you to figure out what is actually your array boundary and whether you are going to access it beyond that boundary. It's your duty, not the duty of the C compiler. Okay. Okay. So, okay. So I hope that this is fine, right? So I can allocate an address to P, but I cannot allocate anything to A. This is not allowed because it's a static array. It can be P equal to A, P can and A0, P equal to A plus 5, or and A5. Okay. Yeah, tell. Okay. So if I for example, okay. So this is one way of dereferencing things. Okay. But maybe I write it this way. If I have P something like this, Pi is basically same as star P plus I. This is another thing of syntax. Okay, so here also, if I use AJ, this is same as star A plus J.
So simply A is A0.
Simply is A plus 0 or A0, yes. Okay, so A is same as and A0, or also same as A plus 0. Okay, A plus 1 is the address of the element at index 1. A plus 2 is the address of the element at index 2, and so on. Here I am dealing with integer arrays, or it may be an array of characters, it may be an array of structures, whatever that size of that each individual element is, plus this thing will take care of that. The amount of skip will be 5 times size of that thing, whatever the individual element of that array is. Okay. Okay. Tell if you have a question.
No, sir. Sir, means I had one doubt regarding arrays. That suppose we have declared an array of 10 integers. Then can we say anything about the value stored in A minus 1 or A11 or
Yeah,
A10
that's
means?
what I told. It is outside the legal boundary of your array. Here is memory has something there. You can go ahead and access.
But means we cannot necessarily say that that value will be 0
You
only.
cannot necessarily say whatever is sitting there, this is something. Okay. It may even be outside your permission area where you can access.
Okay, sir.
Enter your duty to ensure that you are accessing in the legal part of the array. If you do not do that, the day is not for you. You will have very unwelcome bugs and similar things. And debugging such codes, of course, I would say that in general, people do not do it deliberately. These things sometimes happen by mistake. And if it happens by mistake, finding out the real bug is a real headache. Take my word for it. Maybe you will face sometime in your life during this lab or something like that. Even if you do not do it deliberately, it happens by mistake, by chance, then finding such errors is a very difficult job. Unfortunately, C is like that. Okay.
Okay, sir.
Excuse me, sir.
Yeah.
Sir, like the arrays have negative indexing as well. Like so,
Now,
like do arrays also have like real numbers as an index? Like is there partition
no,
as such?
real numbers is not possible.
Okay.
Real number is not possible because I told you. That is, if you want to access AI, the compiler will look at the address A. Okay. Then what it will do, I times size of array type, whatever type is. It's int, it may be structure, it may be character. This is a simple way the compiler will compute the address, go to that address, okay, and whatever is sitting there, it will try to access that. That's it. It has no headache of checking whether I is positive, I is negative, A is a valid address, okay. But A should have a data type, okay, an int type or struct std type, whatever. The compiler needs only this initial address A, whatever index you specify, positive, negative, 0, whatever, it doesn't matter. It also needs to know the type of the array. Then it can just compute this address formula, go there and try to access. Then what happens if it is outside the legal boundary? It's your headache, not the headache of the C compiler. Okay.
Okay, sir.
Okay. Okay, so I will then write to a couple of programs illustrating more on these arrays and pointers and functions and all that stuff. But let us have a small break, maybe a 5 minutes break. Okay, so I will come back. Hello. Yeah, so I am back. I will write a couple of functions illustrating the use of this equivalence of arrays and pointers. Maybe first I do one thing on character array strings. So you know this function, right? strlen. Yes or no?
Yes.
It computes the
Yes, sir.
length of a null terminated string. But I will write my own version of strlen. My strlen. Here I will pass my string str. Okay. But I could have passed it in this format, right? Because it is null terminated, I do not need to send the actual number of elements. But what I will do, in order to illustrate that, I can also just send a pointer. Because pointers and arrays are essentially the same. Okay, so I can do it. Then I will just say int len equal to 0, and p is the character array that you have passed. So I will just write this while star p. In fact, I can do it in a more okay. So in reality, the strlen function is written in a fashion like this. Am I doing it correctly? I think so. Okay. So I will write the main function and let us see what happens. And let's say A1000 to just initialize to my name. Okay. And let us have some length variable here. And let us just call len equal to my strlen a. What do you expect? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or instead of just having it, I will just print it. It should print 11, right? Okay, so 11. Happy or not? So what does it do?
Sir, how does while stop?
You have tell. How does while stop?
It will stop when it reaches the end of string null characters \0.
Stop when it reaches
Oh.
the when it reaches the null character, because the null character has ASCII value 0, right? And this is pre-increment. So the value of p is returned. Okay, it is incremented and the pre-increment value is returned. And if it is star p, if that thing is something non-zero, length will be increased. If it is 0, the loop will break. Yes or no?
Yes, sir, got it.
Got it, right?
Yes.
I'll do another thing. What should it print?
Excuse me.
Yeah. Yeah, well.
It is counting null. So it is counting null terminator.
It is. Your microphone is pretty bad.
Abhijit,
Either your
sir,
microphone.
you okay, right? It is returning how?
Sorry, what another explanation of this function? I could hear only 20 to 30% of what you said. It's breaking. Okay, so let's see. So initially P is
Sir,
pointing.
I'm saying that your
This time not even 10%. Let us see. Let us draw the picture and let's see what happens. It is a null terminated string, right? So at some point of time, after this string ends, there must be some null character. And actual array size was something like 1000 or something in it, right? So what I did, initially I passed P.
sir, it is counting null terminator or blank space.
Maybe I will just clear it up a little bit. That will help you understanding. Okay, let's do it this way. Okay, let's do it this way. Whatever I have written, it was doing exactly the same thing, but this may be more readable. Okay. So this version is, I think, better for your understanding. Okay, the earlier thing was also correct, but it's more stylistically written and therefore maybe there is a confusion. Okay, so you come here. Okay, at this point your length is 0. Okay, then you are checking what is star p. You are see that this is a. This is not the null character. It is some non-zero ASCII value. So you're increasing length. Length becomes 1. P now points to this. Okay. Then you are checking whether star p, whatever p is pointing to, is the null character or not. Still it is not. So length will be increased by 1 more. P will also be increased by 1 more. So this will become 2, length will become 2. This is the evolution of length. P will come here. So length will become 3, length will become 4, length will become 5, length will become 6, length will become 7. Then I encounter the space character, which is actually ASCII value 32, 9, 10, 11. Then after this final thing, I have this plus p. P will now point to this. Okay. By this time, length has stored the value 11. Okay. Now, when I access star p, I see that it is the terminating null character, which is ASCII value 0. So the loop will break and simply 11 will be returned. Yes or no?
Yes, sir. Now I understand. Yes,
Now
sir.
it is
Understood.
clear, right?
Thank you, sir.
Okay, so whatever I have written earlier was doing essentially the same thing, but in a more stylistic manner. And so let's forget it. Okay. Now let's answer this question. If instead of a I pass a plus 5, what will it return?
6.
6, right? Because a plus 5 will be a plus 0, plus 1, plus 2, plus 3, plus 4, plus 5. So p will be initialized to this. Then it will count 1, 2, 3, 4, 5, 6, and then it will encounter this null character and it will stop working there. Okay. Break the while loop and all that stuff. So it will print 6. And if I say -1,
size of char, we want to print some.
no, +5, this is A is of type character, right? So +5, I do not have to say +5 times or star size of char, because pointers are typed. So when I say A +1, I will mean whatever, skip 5 characters. If this is a struct std type, when I say +5, whatever the amount is necessary, skip those 5 element types. So that's the formula. A, base address, offset. Okay, but you just write A + I. The new address is calculated like this. The size of is taken care of by the compiler. Okay, you do not have to specify this. Was it your question?
No, sir. Suppose we want to print size of char. It is 1000 now. Then
Size
what
of
will be our
character.
logic?
Size of character is okay. I will print. I will print. Okay. Since this is a question, I will print. But before doing that, let us try to understand this. What if I say my strlen A -1? What will it print?
Sir, 12.
12. Any other suggestions?
Not predictable,
Not predictable.
because we don't know what is stored in the address A-1, ASCII value of that. It may be 0, it may be not 0.
Because in case a null character is placed there, it would directly print
Break.
0. Yes, it
Yeah,
would
so
break
there are
at
two
the first
possibilities. A -1. So you are accessing this. You do not know what is sitting there. If the null character sits there, this will return 0. And if something other than the null character sits there, it will return 12. Okay, so the only two possibilities are 0 and 12. Let us see what happens here. Okay, it prints 0. So null character is sitting there. Why? I don't know. But you have no control over that, right? It turns out that this null character.
Sir,
Yeah.
can you do A-2, sir? Can you print A-2 that we can predict?
Again, of course, I can do. But again, you can see maybe 0, maybe 1, I don't know. 0. So it seems that this part is filled with 0, 0, 0. How many times I do not know. And if I do something very audacious, is it a million? Yeah, it's a million. What should it return?
It can be happening that we are accessing a memory that is not accessible to our code at all if we go too far away.
Let us see what. Oh, it is still inside my code, so it's returning 0. Maybe I increase it further. Yeah, segmentation fault. Understand? So if you want to access beyond your legal array boundary, it may return something like this, over which you do not have any control, or it may even encounter segmentation faults. Okay, so do not deliberately do these bad things. Okay, it's good to know that some such things may happen, but it is preferable not to do these things deliberately. By mistake, this will happen. Okay, take my word for it. By mistake, this will happen, and then you will have a huge headache to debug your code. Okay, so then somebody told something about size of. Let us print this.
Sir,
Let me just print this. %d, %d, %d. Three things I will print. First, size of A0.
Sir, I meant write my own size of function, just like str.
What?
Write my own size of function. Can we do that?
It's a very difficult thing because size of takes several things. It may take a variable name. It may take a variable type. So what kind of thing are you, size of it, it's very difficult to write. Okay. So it's not a macro. It's not a function. It's a feature of the C compiler. Let's see what it happens. What are the differences of size of, this is a character, it should be 1. This is actually a character array. So it should be 1000. And size of and A0, it's just a pointer, so it may be 48 bytes, so maybe 8. Let's see. Ah, yes. Size of actually text unsigned, perhaps unsigned, long unsigned. Value. Okay. Okay, in fact, that is the difference between this. If I just say star p and simply say p equal to a, and then I print the size of p, it will be the size of a pointer. 8. So size of A is 1000, whereas size of P is 8. Size of this pointer and A0 is also 8. Okay. So although arrays are pointers, the static arrays are not exactly as pointers in terms of size of. Size of essentially returns the allocation size. Okay.
Sir, didn't understand size of A0.
Size of A0? What is A0? A0 is just a character.
A0 is?
It's a character. So it is 1. 1, right? A is a static array with 1000 characters, so its size should be 1000. What?
So size of %
And A.
In that P simply represent %0.
I suggest let us not use this. We have seen in the last class that size of and A actually works, but I do not know. It may be very specific to my compiler. It should actually make no sense. I can write, since you are insisting I can write. Size of and A will be a pointer, so it will be 8. But try to.
Excuse me, sir. So in array and pointers, only size difference are there. That's it. And it is a static and pointer is dynamic.
Yes.
These differences are there. Okay.
And that is reflected here, and that is also reflected in, you cannot say A equal to something, but P equal to A you can write, A equal to P you cannot write. So in some respects, static arrays are different from pointer, but otherwise they are similar. Okay. Happy or not? And I suggest that you preferably do not use this and A, because to me it does not make any sense. Okay. In fact, it is clearly written in the slides that and A makes no sense. Also, I do not make any sense out of it, but my compiler is supporting and A. So what is the physical interpretation of it? I don't know. I simply don't know. Okay.
Sir, can you explain why 8?
Which one is 8?
Sir, size of ampersand A0.
It's a pointer.
So pointer size is 8.
In my machine, it is 8. In your machine, it may be 4. It depends
Sir,
on it.
because sir, character is 4-bit, right? I mean,
this is not a character. This is the address of a character. Understand the difference.
Yes.
Okay. P is also a pointer, an address. A0 is a character. That is why its size is 1. And A0 is a pointer to a character, so its size is 8. Okay. Never forget this. Okay. I didn't understand anything. You can write your doubt, yeah. The net is either bad or your microphone.
Hello, sir.
Yeah, tell. You write your queries. We cannot hear anything from you.
Sir.
Otherwise.
Hello, sir. I have a different doubt. If we declare two different types of pointers like character star p and integer star p, then both of them will have the same size, right?
Yeah, they are pointers. They are both pointers.
Means pointer has a fixed size on a fixed compiler, like
Pointer
8 bytes or
compiler, yes.
Okay, sir.
Because pointers are addresses.
Yes, sir. Okay.
Looking at this example, can we say that P is same as? Yes, it is. It is. Yeah, it is. Yes. Where is the? I mean.
Excuse me, sir.
Yeah.
Sir, can we add the third element, fourth element, the later elements in an array before the initial elements in any order, or will it affect the array?
The question is not clear.
Sir, means can I define A3 equal to 2 and then A1 equal to 1, and what will happen to the middle elements which I have not defined? Means every time in a for loop we go from start to end. Instead of that, if I want to make it random.
Go ahead, do it. What is the problem?
Sir, it would, sir, it works.
Yeah. Why should it not work?
Okay.
This is the formula. The compiler, you say, if I want to do something, it will look at the base address A, I times whatever the size of the array type, element type, and whatever you want to write there, write. It need not be sequentially written. It need not be, in any particular order. Yeah, no problem. Undeclared element set to 0. No. If you partially initialize an array, then only this will happen. But if you do not make any attempt to initialize an element, initialize an array, then it will contain garbage values, not in your control. But if you initialize it partially, then the remaining things will be set to 0. But if you do not make any effort to initialize it partially or totally, then you cannot say anything about the array elements. After initializing, yeah. If you do not supply sufficient number of initializing values, then the remaining things will be set to 0. But provided you make an attempt of initialization. If you do not make an attempt, then it will contain garbage values. Okay. Yeah. Okay, so I think I would write a second function illustrating a more complicated example of this type. Okay, so for that matter, I will use some 20, maybe 2, 5, 3, 1, 9, 3, 4, 6, 7, 9, 8, 3, 2, 1, 7, 5. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 4 more. Nine. Okay, I could have also written it as random initializers. Anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 20. Okay. So the array size is 20, at least this much we know. What I will do, okay. Array sum A 20. So I will write that function. Okay. So I will write a recursive function array sum. It will return an integer value. Instead of int p square brackets, I am just writing int star p, and also I'm giving some function, some length. If n is 0, what should I return?
So 0.
0, right? An empty sum is always 0. Tell sum, right sum. P, but the size will be n by 2. Right sum skip the first n by 2 elements. So how many elements will remain? N minus n by 2. Okay. So if I count this, 20, 33, 40, 60, 70, 79, 81, 93. Okay, let's see whether it returns 93.
Sir, base case is not complete.
Why?
If n is 1, then we should return p0. That condition also we need to write. Otherwise, how will it terminate?
Yeah, you see. Oh, I see. Then you have 1 by 2. Oh, okay. Oh, it will be an infinite recursion, right? 1 will simply break to 0, 1, 0, 1, 0, 1, 0, 1. Okay. Case 1 we have to handle. Yeah. What should I return? P0, right?
Yes.
Yes, sir.
P0, or I can also return star P. So same thing.
Star P.
Okay. What is this name? Recmin. Oh, actually rec sum it should be. Anyway, I wanted to compute the minimum, then I changed to. Okay. 93. Okay. So what it does, if n is 0, I am talking about an array of size 0, but in that case, of course, unless I give you, okay, anyway, doesn't matter. Okay, fine. Return 0, n is 1, and then I'm talking about an array of size 1. So its only element is p0. I can also write it as star p. Otherwise, I recursively compute the sum of the left half starting at the same address as p, but containing only n by 2 elements, and the right sum start at the same address and then skip n by 2 of the elements, and then you are left with n minus n by 2 elements. Then you simply add them up and return. Okay. Now if I do something like this, sum of elements of A, let's say 5 through 9. So that means 0, 1, 2, 3, 4, 5. This is 5, 6, 7, 8, 9. 29, right? If I want only this sum, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, this is only 5 elements. Then I should call it as A plus 5, or maybe it's not a good idea. I will make it slightly bigger, 5 to 11. Then this is 5, 6, 7, 8, 9, 10, 11. How many elements are there? 7. 7 elements. So I will have 5, starting from 5, and only 7 elements. What is the sum of this? 7 plus 6, 13, 20, 29, 29, 32, 40. Okay, it should return 40. Yeah, 40. Okay, so this point time notation actually gives you a great flexibility. You can handle this sub array, right? 5 to 11. Just say a plus 5, start at 5th location and consider only 7 elements. Happy or not?
Yes, sir.
Okay. Okay, then I have just one more thing I wanted to say, although this is not a part of this slide. I had a 2D array type, maybe I just in 5 minutes I just cover it. Okay, so I have some row dimension R10, column dimension 20. Okay. Let me first do one thing. %d, okay, LU, A0, A00. Can you tell me what will be the answer? What is the size of A?
Sir, 200.
No, not 200. 200 times size of int.
Oh, 200 into 4.
800, right?
Yes, sir. Yes, sir.
What is A0? Size of A0? Oh, sorry. I forgot the size of thing. Last one is easy, right? What is A00?
1.
It is not. Yeah, it is no, not 1. It is what the size of int is.
4 then.
4. But what
Yes.
is A0?
4 into 20.
4 into
4
20.
into 20.
Okay. A0 is actually a row. The 0th row. Okay. So if I now, whatever the name I have given, 2D array type dot C, 10, 20 times 4, 800, 80, and 4. That is what we expected. Now the question is that, like one-dimensional arrays, this A is also a pointer. Yes or no? This is also an array, but this is also a pointer. So the question is, what kind of pointer is it?
Pointer of a row array.
Pointer of a row array, or you can say pointer to pointer. But if I do this, let us see what happens. Just let us see what happens. Let me just compile. Warning, variable p, okay, forget that. Assignment to int star from incompatible pointer. Okay. So this pointer and this pointer are not of the same type. So as somebody pointed out, this A is basically a row pointer. Okay. A0 is a row containing C int elements, and that is why its size is 80. Okay. So how do I define it? Here is an easy way of doing it. So if I say int column 20, what does it do? sorry, int row 20. Okay, this basically assigns or allocates an int array of size 20. Okay. If before this I just say type def, then row now becomes a type. It's no longer a variable. It says that row is a type. What type it is? It is an array of 20 int variables. So now if I say, sorry, p is a pointer, sorry, no, not here. P is a row pointer, then there will be no problem. Okay, so instead of 20, I will just use C. Anyway, it's the same thing. Now let's try to compile it. Okay, so now this is a different message. Variable P set but not used. P is now a row. P is now a row pointer. Star P is a row. And star P, let's 1 second write down. What is the size of P? What is the size of star P? And what is the size of star P? P is just a pointer? Yes or no? Whether it's a row pointer, int pointer, it doesn't matter. It's a pointer. So its size will be 8. In my machine, addresses of size 8, so it will be 8. What is star P? Star P is a row, right?
Sorry,
Yes
the
or no?
address in the row. Yes, sir.
But a row is nothing but a one-dimensional array. Then what will be that? That is once again a pointer. Yes or no? So its size will again be 8. And what is star P? This is now an int variable. Its size will be 4. So you expect 8, 8, 4. Let us see what happens.
Can you repeat first size of P?
Oops, it's 80. Ah, not 8. I see, it is 80. P is what? P is a pointer. P is just a pointer. It doesn't matter whatever it is pointing to. Right? Whatever memory you require to store a pointer, that is an address, that will be the size of P. Oh, star P is basically a row. So here it is not, I see. Oh, I see. So star P is same as row. I see. Star P is same as row. So whatever the size of row, that will be the size of star P. That is 80. I see. Okay, so it's not a pointer. Yeah. So there are subtle differences between static and dynamic arrays. Good.
Sir, star P will denote row 0, right?
Yeah, that's just an integer, right? The integer has
0th element of the array.
0th element of the 0th array, 0th row. But that is just an integer, so integer has size 4. So this is consistent, no problem.
And star P is like dereferencing a pointer.
Star P is basically same as row. So whatever the size of row is, that will be it. So I made a mistake. It's 80, not 8. It's not a pointer. It's basically this type def.
Sir, one
And
question.
sir, if we type def integer array, so if I write row C, then C will denote a row of 20 array of 20 integers, right?
Uh-huh.
That is my doubt. Means type def for arrays is a bit confusing for me. That's the difference.
So how do you declare an int variable?
Int n.
Int n, right? If I say instead of this, I just write type def int n, then n will no longer be an integer variable, but it will be just be a rename of int. Okay. So in any place where you declare something like this, int arc, okay. Okay, so if I say int arc, it essentially declares a 2D array. If I now say type def, okay, and give it some name, maybe matrix, then there will be no variable. Instead, there will be new type, which is same as int arc. So instead of doing this, I can now say matrix A. It has the same effect. In fact, there is a more complicated way of doing this. Another pointer. If I say simple okay, I need a pair of parentheses, but why this is necessary? This is a little bit complicated. I can say q equal to a. Let us see what happens. Oh, sorry. I should have int star q. What is that? Column dimension. Yeah. Now this will be fine. Now it is said but not used, but I will do the same thing here. Size of q, size of star q, size of star q. Same thing. Okay. But if I forget this, then there is an error. Okay, error. Assignment to expression with array type. So this is not allowed. But if I say something like this, then this will compile. But why this is true, you do not need to worry too much about. If you are interested, you can look at the I would say PDS online notes posted to the CSE PDS website. But I think this is a good way of viewing it. First, define a data type, row.
Excuse me, sir.
Yeah.
Sir, size of a star P is 80. How it is coming? Can you explain?
Size of star P. What is
yes,
star
sir.
P? Star P is nothing but row. Star P is of data type row. And what is row? It's an int array with C elements. So 4 times 20 is 80.
Sir, size of one int is 4 and it is of dimension 20, so it is 20 into 4 equal to 80.
Exactly. But, okay. So this is just, I was trying to explain what kind of array, what kind of pointer a two-dimensional array is. Okay. So maybe I just remove this part. Let us just have int a row column. Okay. Okay. Well, it's told 5 minutes, but I have taken 15 minutes. Yeah, let's stop here. Okay, so Two-dimensional arrays also have a pointer type, but that is not obvious. Okay, anyway, we will see another kind of 2D arrays tomorrow, hopefully. Let me stop.
Excuse me, sir.
Yeah.
Sir, what did the minus WALL that you wrote while compiling did?
Warn all. You see that I
Sir,
am
what?
getting warning messages, all warning messages.
Yes, sir.
So it just says variable Q said but not used. Things like that. Okay.
Sir, so if I don't write it, I won't get warnings.
Some warnings you will get, but I am saying that you give me all warnings.
Okay, sir.
Okay, so it's a good practice to write W all.
Okay, sir.
Okay. Some serious warnings will anyway be issued, but I am asking for all warnings. Because if my program compiles without any warning message, it's picture perfect. Right, and that's what we want it to be, right? Yeah.
Sir.
Yeah. Yeah, I think it's already a long session. Let us stop. What do you say?
Yes, thank you, sir.
Yes.
Thank you, sir.
Tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir.